All right, folks, let's dive into the fascinating world of artificial neural networks, also known as ANNs. These are computational models inspired by the human brain, designed to recognize patterns and solve complex problems. If you've ever wondered how these digital brains think, you're in the right place. Today, we'll break down the inner workings of ANNs in a way that's easy to understand. First up, data is fed into the neural network through the input layer. This is the initial stage where all the raw information is gathered. Think of this as the network's senses gathering all the raw information it needs. Just like our senses collect data from the world around us, the input layer collects data for the network to process. Next, we get to the hidden layers. These layers are called hidden because they are not directly visible from the input or output. They perform the crucial task of transforming the input data into something meaningful. This is where the magic happens. These layers talk to each other through a system of weighted connections. Each connection has a weight that determines its importance. Picture these weights as importance markers, telling the network which inputs matter more. The higher the weight, the more influence that input has on the final output. Inside these hidden layers, we have nodes. Nodes are like mini decision makers. They take in data from the input layer, combine it with a set of coefficients, and assign weights to these inputs. It's like mixing ingredients for a recipe, but with numbers. Each node processes its inputs and passes the result to the next layer. Once all the inputs are weighted, the node sums them up. This sum represents the combined influence of all the inputs, but we don't stop there. This sum has to pass through something called an activation function. The activation function adds a layer of complexity to the model. Imagine this function as a gatekeeper, deciding how much of the signal should move forward through the network. It introduces non-linearity into the model, allowing it to learn more complex patterns. Now, why is the activation function important? Well, it ensures that only the most relevant signals make it to the next stage. Without it, the network would be limited in its ability to model complex data. This is key for making accurate predictions or classifications. The activation function helps the network to focus on the most important features of the data. This is key for making accurate predictions or classifications. The activation function helps the network to focus on the most important features of the data. Finally, all the processing done in the hidden layers leads to the output layer. This is where the network delivers its final answer. Here you get your results. Whether it's recognizing handwritten digits, predicting stock prices, or even more complex tasks, the output layer delivers the final answer. And there you have it, a quick tour through how artificial neural networks think. Complex yet fascinating, right? These networks are powerful tools that can solve a wide range of problems. If you enjoyed this breakdown, don't forget to like, subscribe, and hit that notification bell for more cool tech insights. Thanks for watching. If you enjoyed this breakdown, don't forget to like, subscribe, and hit that notification bell for more cool tech insights. Thanks for watching.